We will start today with the ISO IEEE 11073 standard. And obviously this is a medical-oriented standard, but I think it is relevant for other potential environments or domains, because it relates to interoperability of devices in general. Of course, in this case, this standard has been carried out. I would say the origins would go as back as 1984, something like that. And it has been evolving a lot because technology has also evolved, particularly, for example, it covers the whole 7 layers of the communication stack, and those related with the physical layers have changed a lot already. So this is something alive and it is changing over time. But I think it is a very interesting exercise for you to analyze to what extent it could be useful in your particular domain. Or probably you may already have some parallel standards in the same sense, and maybe one of the things for values is that we are able to cross-fertilize the activities in different domains, and maybe we can provide some good inputs to the standard developers. This standard is still under evolvement, and it is a huge stack of standards really in itself, because it covers every single device that can be connected to a patient. So you can imagine how many sub-standards there are in this particular one. So to start with, this standard is called Health Informatics, Medical and Health Device Communication Standards. And it enables the communication between the medical, healthcare, and wellness devices, and also the connectivity to the external computer system. They provide automatic and detailed electronic data capture of client-related. The client would be, in this case, those devices connected to the patient, which are the ones that get the vital sign information and transfer it to, let's say, the manager that collects information from every device. This standard has been created with a huge number of cooperations from different organization standards. For example, RGB has been a member for many years in the CEN ISO IEEE 11073, but then it became an ISO standard already. And it is, let's say, accepted by different organization standards that run in parallel. There are some keywords in this standard, but probably I think I will, in parallel to this explanation of the main features, I will go to this figure to show you that essentially when we have a patient and we connect a device to a patient, we're monitoring it for some particular purpose. One of the purposes could be, like it is the case of our use case, use case 8 in values, which is neuromuscular transmission control. It could be even not only monitoring the parameter, but actually infusing drug into the patient in order to achieve a specific level of muscle relaxation in this case. But it could also be another parameter like blood pressure, and we want to control the blood pressure by infusing drug. So the level of complexity can be enormous regarding the type of devices that are going to be connected. For example, the most complex area would be the operating room, but it could also be critical areas like intensive care unit. But this standard in the last years, for example, has been moving more towards even the home and the fitness centers as well. So we go into telemedicine aspects. Now, the monitor, when it captures information, it will get information from vital signs in different ways. For example, if we are taking the temperature of a patient, this is a parameter only, a number, or a pulse oximetry, that is the oxygen in blood. It is a percentage. Or we can set the rate of infusion of a particular infusion pump. That would be another type of information. The most, let's say, obvious one would be the waveforms that are time varying, like ECG, electrocardiography, or blood pressure. But sometimes we want to correlate parameters. We don't want to draw them in relation to the time, but one with regards to the other, like pressure and volume, and we can get some kind of interconnection between two parameters. So you can imagine there is a lot of differences in the type of information that we are actually extracting. Not to say, for example, images, which is another medical information that requires a specific ways of capturing and transmitting. And then there is like a third axis here, which is related to the topology, related as well with the specific application. It is not the same, for example, if it is a point-to-point connection between a monitor and a computer. For example, here we have the case of an electrocardiography analysis for effort test on a patient to see how the patient reacts when he's subject to doing a specific effort. Or else we want to go to the internet working inside the hospital between different wards, going from the most extreme and critical to others, like, for example, the operating room, then you go to the intensive care unit, and then you go to the standard wards. So there are different areas in which you want to have still the connectivity. For example, for cardiology, you want the patient to be in the ward, but monitored by the intensive care unit, and you are actually monitoring the patient with many leads connected to the patient and getting the ECG waveforms and being transmitted to a specific central station where all data is being captured. So while I'm telling all this to you, please be thinking in parallel to what other things you can think of in your particular domain. But I think this area is covering a very broad number of devices and parameters that actually have been considered to an incredible level of detail for every particular monitor. And of course, things like capability of expansion of the norm, because there are new devices all the time coming up, new parameters being measured, and all these things have to be considered from the beginning. So this is not a closed standard that does not allow the evolution of technology, but it has to cover the improvements that may be appearing over time. So having said this, we go back to the previous slide, and now we can understand better the concept of this standard. On one side, real time. We are talking of real time. We are capturing data, and we are intending to work on a real-time basis. This is absolutely critical. Uh, Plug and play means that I only have to connect the device and I don't have to bother anymore about how to configure it. The system will do all the configuration and all the connectivity so that the new parameters can be looked at without any additional effort. Efficient exchange of care device data. If we are able to capture information from a patient from different sources, the number of new applications that can appear is enormous. We can find new parameters as a combination of previous ones. And this is only possible if there is this real-time capability by which we have a complete overview of the status of the patient in many areas that before used not to be correlated. And all of a sudden we have all the information in one place and we can do some new and extraordinary things with this information. So although the standards are targeted at what are called point of care devices. Point of care means they are in connection with the patient, like a ventilator, an infusion pump, electrocardiograph, etc. It is also related to personal health and fitness devices. For example, glucose monitors, pulse oximeters, weighing scales, medication dispensers, activity monitors, and continuing in acute environments, the continuity of care is very important here, so that the patient will be at all times monitored, even if it is moving from one specific area to another. And that covers the whole range of devices as well. This must be solved for different environments. Some are very critical and others are not, like the home, but it also goes to the home. Okay. As I said before, this ISO 11073 is a family of standards. In fact, it is not only one. That's, I think, one of the good things of having these workshops is that if you don't find it interesting, you don't have to buy it, which is very costly after all, because the number of standards is huge, no? But we try to focus on those areas that are more interesting for you and for your specific domain. And as I said before, maybe they are not related directly with your activity, but they have some parallelism, and you can use it, and you can inspire other standard developers in your area to use these techniques. It's interesting that a language is built up when doing this connectivity. This data, medical data, is around and is built up around a nomenclature or terminology, which is correlated with the vital signs information representation, and it's all coded. Let's say the codification takes place in a way that in the end all what is transmitted is to some extent codified information, and based on what is called the vital signs information representation. Probably for me, this is the most important part of the standard, because after all, the way you communicate is something that is outside the scope, even though it is used by this standard, but it is outside the scope of the standard in the sense that there are already other standards covering that area. But how you represent the information, This is really an object-oriented data model, and I think here this is where the system is quite innovative, even though it is, as I said before, it comes from the 1990s, so it is not really that modern, but still it is quite advanced. The services at the application level can be done with different types of connectivity. For example, POLD, which would be there is a consultancy at regular intervals on a particular value and an updating of that value over time. But also the information can be event driven, so it is communicated with when something happens. And of course, this, let's say, this whole technical solution is also interconnected to other systems. For example, the information hospital system, which is a different concept in the hospital, and it contains administrative data like the patient data or the credit card information, things like that, and the information is interoperable with all these other standards. For example, DICOM is related with images, so that yeah, the information is captured and transferred to DICOM norm, and the DICOM is as well part of the information that is manipulated in this standard. At the transport layer, we have different means like cable connected or wireless technology. So this is an overview of what we can have, starting from the, let's say, the area of the patient, where the patient is, could be radiology, cardiology, intensive care unit. On the other extreme, this is the hospital information system, which is the information system of the hospital in general with administrative data. But in between, there are at device level, departmental level, or hospital level, there are interoperability as well. So, for example, in radiology, essentially we are getting images and we are using DICOM, and we are using information, archive information systems that convert this information into something that is finally transferred via HL7. Here we have the position of ISO 11073, which is essentially related to the connectivity of all type of devices that are using vital signs like stress Holter or cardiac monitors, etc., etc., bedside monitors, for example. Then we have the ISO 11073. So what problems are we solving with this standard? If we would not have it, we would have to work manually, let's say. And this is what has been done and is being still done in many of the hospitals around the world. It means that the nurse is picking up data with a pen and a paper and drawing it in a normally it is a large sheet that you write the evolution of these vital signs over time. So we are going to obviously a much more sophisticated system, but in the end it doesn't require so much time, and we are not prone to human error. This is automatized, and especially because we have all the information in one place, we can really get advantage. Not only the cost of care delivery is lower, but we also have pieces of information that used to be apart. We have them together, and we can build up new technologies with this information. So this is a typical setting this would be intensive care unit, for example, or in the operating room. You can imagine that the patient, on one side, it has a ventilator, but the ventilator is also delivering some drug into the patient through the air, we are also having infusion pumps that are intravenously injecting drug into the patient. We have a monitoring of all types of device. And the good thing is that now we can interoperate the components, and we can have a complete overview of the status of the patient. In the past, this was not possible. So we will be using this standard to to do the integration of data and the connectivity to the storage areas. So essentially, I think more or less you get an idea of what problems we are solving. I don't want to extend myself much more on this, but essentially this standard is going to provide better delivery of health and continuity of care, because it will go and provide information of the patient all along his lifetime in the hospital environment or the care environment, from the hospital, from the operating room, even to his home. So it's very convenient. Well, this slide is to tell you, I will not go through it, but this is to tell you to what extent this norm has been in contact with other norm developers of various, let's say, layers of the communication stack. Therefore, this is the only one that there is at the moment for interoperability. At the same time, I must say it is a very complicated norm to implement, and there is what is called Continua Health Alliance, which is like a specific company who has not a benefit or a profit target, but has the target to help manufacturers to implement the norm inside their devices, and they provide assistance to this work. There is here, as it says, the Continual Health Alliance specify the use and give you a certificate of compatibility with the norm. So it is growing up in numbers of devices that are already compliant, but still there is a long way to go here. Again, the same, just as an overview of the standard, just to summarize, there are many interconnections with other standard organizations, and this family of standards defines parts of a system with which it's possible to exchange and evaluate vital signs data between different medical devices, as well as remote control. Remote control is like an additional feature that was included, because there are many occasions that you need a remote control on a patient, not only in the case of drug delivery, but air delivery, for example, in the case of a ventilator. Here is only a subset of the standards that are related. I will not go through them, but each of them has a different role. In my opinion, the most important one would be those related with the domain information model, particularly for other domains, but it is interesting how it is organized, the information, and also the nomenclature that is used in order to categorize each device and each particular vital sign. There are other standards related with the communication stack. like this ones in the end, transport profile, for example, which in my opinion obviously are evolving very quickly, and every time there is a new technology for communication, it is incorporated into the standard. But this is not really the core of the standard. Okay, so the ISO 11073 personal health device standards are a group of standards that address the interoperability of these are devices that are not so critical, but for example, they are used in the homes, like the weighing scales or the blood pressure monitors or blood glucose monitors, but still they have contact with the patient or with the, in this case, the user. No, these are normally people that don't have to be ill, but they want to be fit, and they take care of their body. And then this is like a different line of activity that has emerged in the last years. But obviously it is using the same connectivity means. Okay, let's go now to how the nomenclature is solved. Within this standard, the codes for nomenclature are defined, and they give the opportunity to identify objects and attributes in relation to the object identifier code. The nomenclature is based on concepts, and the way it is done is something like this. If we want to express the triangle, the triangle with the background in black, we would classify the information something like this. For example, we want to say the area in this particular triangle. It would be, number one, the concept would be what we want to do, the area, then of which specific component, and in this case, in circle, so it is the one that is indicated. So there is like a base concept, then there is a semantic link to a number of descriptors, first, second, third descriptor, as many as necessary in order to reach a specific concept. And in the end, it is transferred in the case of the black area of the triangle. It would be geometric figure, has shape triangle, has color black, has a specification area. And you can think of this concept being implemented for medical vital signs. No, we have like a dictionary of terms for every different application area. For example, electrocardiography or neurological monitoring, etc. And the type of thing would be something like this. There is a code in the end, 19252, that is related to a common term, arterial oxygen saturation, that is the oxygen in blood. And then we would have a systematic name based on these labels, like concentration of saturation oxygen in arterial blood, and blood chemistry. So there is a code in the end for every particular vital sign. You can imagine the huge amount of work, and also there are means for extending this coding when we are referring to new parameters. But in the end, we have to have implement in place a kind of organism that keeps track of the coding, so that we all agree on the specific numbers. Now we go to the core, the heart of the standard, which is the domain information system. Within this, what is called the MDIB, Medical Domain Information System, information base. The objects and the arrangements in a domain information model are defined. It is like boxes that we collect all information and put it in a specific box. It is all organized, and we need to be sure that the information that is contained in a particular box is updated at all times. We also have a communication model, but I will not go through that. I told you already, the communication model will be related to the transfer of information between what is called the agent, that is the information in the medical device, and is the generator of data, and the manager, which is the one that captures all as a receptor, captures all the information. So the communication model is related to the layers 5 to 7 of the OC7 layer model. So you can imagine this is a rather old standard. This is still something that has to be changed. The concepts are still quite old. And that's why I don't particularly like this part of the communication stack that is here. But this is the typical image you will see. There is an agent and a manager. There is a medical device information base, which contains the objects related to the vital signs. And there are like a connectivity stack. ACSE is related with the association of a link and the disconnection of the link. And then the CMDIS is related to the transfer of information between the objects in the agent and the objects in the manager. The manager is like a mirror of the agent. It contains the information, but not only of this particular medical device, but as many agents as there are medical devices around the patient. So the medical device information base of the manager contains a lot of MDIPs from different devices. Okay, so the agent is the part that is connected to the medical devices and provides the data, and the manager keeps a copy of the agent data and reacts on update events from them and triggers events on the agents. Okay. But it's interesting the way it is designed, because you can reverse the process and you can make the agent become a manager and vice versa, right? But this is the way that things are implemented. This is a typical view of the standard. These are the tree oriented connectivity between the different objects that refer to the particular medical device. I will put some examples later. And what is very interesting here is a particular object that is called the scanner. The scanner is an object that you create in the agent and will be scanning to see if at any time there is an update of information in any of the objects, so that it is transferred directly to the manager. So essentially, the information in the manager is the same as the information in the agent. Okay. As it says, the implementation of the medical device information base and their functionality is out of the scope of the standard. The managed medical objects are stored hierarchically within a tree structure in the same domain information model. And these are and the arrangement of the DIM is the concept that is essentially explained in the standard. This is again the same picture I showed you before. Now with the terminology of the standard, we would say there are medical devices. which have different types, and use metrics and alarms that are specific for the device and controls, and are correlated with patient data, and there are specific communication interfaces. For example, how do we analyze the manager side, or correlated with a set of devices that are the agents connected to the patient. In this case, we have here information on the side of the manager, but it would be looking at devices like a system, and it would be collecting information from every different agent and integrating it inside, and providing an overall information as well as individual information of the system. For every particular medical device, there is a virtual medical device that contains specific information that is logged into the manager. And for the monitor, that is the agent, we have the medical device system, and we have a different box correlated with a specific parameter. For example, a virtual medical device for temperature and a status plugged. We would have a non-invasive blood pressure, or we would have patient information as well. And even for a particular vital sign like temperature, we will have a numeric type of information. The value observed would be 39.1 degrees centigrades, and the status would be okay. So we are, in the end, collecting all the information in boxes, and we have the scanner that is providing updated information at all times to the manager. Okay, this is again the same with the medical device information base at the application level and transport levels, sending messages from agent to manager. Okay, now the CMDIS, this is this one here. Let me see. I think we have seen it before. Yeah, the CMISE, this one, is the one related to managing the medical information base. For example, at the time of creating boxes, we have here different services that are provided. Objects are created, changed, or deleted by services named create, update, delete, and that is part of the activity that is carried out in the CMDIS. For a particular object, we have services that will alter the contents of the object tree, and will be reporting events at any time, so that at the manager there is always the same type of information. Of course, we have the presentation layer and session layer related to the communication stack, but as I said, this is not really the core of the standard. This is another view to the domain information model and the functionalities that are present. For example, we have the archival. This is, well, let me go through the title, which I think is interesting. The ISO 11073 object-oriented model that represents an abstraction of real entities within the medical device domain. So, for example, the archival of patient data and session archive. We understand that session like something that is correlated to the same patient and has to do with a particular timing of activity. For example, if it is the intensive care unit, maybe we consider a session the collected data of one day. No, that is a way of archiving the information. So we have the functionalities of the domain information manager are related to registering historic vital sign data. We have the medical device system, which indicates the type of equipment that we are using. This medical device system contains virtual medical devices. I mentioned it before. It may contain many medical devices, each one correlated with a particular vital sign. What type of signal does it measure? It could be a parameter, or it could be a time evolution, a times oh, I don't know the English name, but like a photogram of the vital sign. And of course, it generates alerts, and the alert is generating a warning that has to be transmitted, obviously. Then, related to the patient, we have the demographics, what information is available about the patient. Normally, it's very important for many operations to know the weight or the height of the patient. That affects a lot in some applications to the drug delivery to be given, whether it is a child or elderly person, whether the patient has pathologies or not, that kind of things. Extended services, these are the scanner that I was mentioning before, that would be related to the keeping updated the information between agent and manager. The communication controller, what type of communication is used? We have in the operating room, for example, either wireless technology or infrared technology or optic fiber, and different connectivity means. But we have to cover those types of communication as well. And this one of control is specifically related to how to control devices. It's interesting to know that it's very recent. Only I think in the early 2000s, it was allowed to acknowledge that there was the possibility of doing remote control, so devices could take therapeutic decisions. This is something that was a great change in mentality when the doctors realized that they could rely more on technology. So, okay, this is a little bit of the same, what everything is: medical package, alert package, system package. I will give you these slides so you can look at them and have a closer look. I want to finish earlier, so if you have questions. So regarding communication model, I will not go very much over it. Essentially, this is not the main aspects. I think more or less I have mentioned about it and about the Continua Health Alliance. Okay, I leave you 7 minutes for questions. So this is the presentation I have prepared for you.